the sine angle identity. And this time what we're going to work with is the cosine angle identity. So we're going to look at cosine x plus y, and we want to express it in terms of sine of x, sine of y, cosine x, cosine y. Now, if you notice in the green triangle AFD, so we're looking at triangle AFD, right? AF is adjacent to the angle x plus y, right? It's adjacent to the angle we care about. So I'm going to write this over here. So in triangle AFD, we have AF adjacent to x plus y, therefore cosine of x plus y is really equal to the adjacent side AF divided by the hypotenuse of 1. So cosine of x plus y is really equal here to side AF. However, I also noticed that if I take side AB, the bigger one, the red one, and I subtract AB and I subtract FB, I'm still left with side AF. So side AF, I can also express it as AB minus FB. AB minus FB gives me side AF. So my problem becomes a problem where I'm trying to find side AB and side FB. So I also notice another thing. This side FB here is really equal to this side EC because FBCE is a rectangle, therefore this side here is equal to this side here. So again, what I'm going to do is, instead of writing FB, I'm going to write minus EC. So now let's look for AB and EC. I suggest we start with EC. I'm going to look at this little triangle over here, ECD. So in triangle ECD, here's what I notice. I notice that the side I care about, EC, is opposite of angle Y. Therefore, I can use the sine ratio. I'm going to say sine of Y is equal to EC over the hypotenuse DC. If you remember though from the previous video, we found out that DC is sine of x. I'm just going to write sine of x. Well, I want to eliminate sine of x on the bottom. So I'm going to multiply both sides here by sine x. It cancels out. And I get EC is equal to sine x, sine y. Great. So I found this side over here. I know it's equal to sine x, sine y. Now, I need to find side AB. AB. Well, if you also remember in the previous video, to find AB, we really need first to know the hypotenuse in triangle ABC. And to know the hypotenuse in triangle ABC, the hypotenuse is equal to AC, but it's also a leg in the blue triangle ADC. And it's an adjacent leg to angle X, right? So I'm going to do a little blue work. We did this in the previous video. If you want, pause and do it yourself. But I'll just give you a refresher. In ACD, CA is adjacent to X. Okay, AC is adjacent to angle X. Therefore, cosine of X will be equal to AC over the hypotenuse 1. So instead of AC, I can just write cosine X. So let's go back to the red triangle. Now that I know the hypotenuse AC, I know that AC is equal to cosine X. And I'm looking for AB, and I know AB is adjacent to Y. I'm going to use cosine. Cosine of Y is equal to AB over AC, or cosine of y is equal to AB over cosine x. I want to eliminate cosine x on the bottom, on the denominator, therefore I multiply both sides, and I get that AB is equal to cosine x cosine y. So AB here, instead of it, I'm going to say cosine x cosine y minus, instead of AC, I'm going to write sine x sine y, sine x sine y. And there it goes. I've got my identity for cosine. Cosine of x plus y is equal to cosine x cosine y minus sine x sine y. What if I want to subtract the angles? So instead of adding, I'm subtracting. Well, as I did in the previous video, I can say that what I'm really doing is adding a positive and a negative angle. And I'm just using the above identity, and I'm going to write cosine x, and then cosine of minus y, and then minus, and I'm going to do sine x sine of minus y. And what happens here is this is an odd identity, so the minus really doesn't matter, but this is an even, just the opposite. I'm thinking the right thing and saying the wrong words. This is an even identity, so the sign here, we can just get rid of it, and this is an odd identity, and the minus is going to come outside. So in the beginning, nothing changes, cosine x, cosine y, but this minus here, there's another minus which is going to come out, so the minus and the minus is going to give me a plus, and I'd end up with sine x, sine y. So here's my cosine subtraction identity, angle subtraction identity. And if you have any questions, definitely call me over or just write to me.